All right, let's get right into it. On any computer you own, your phone, your laptop, even those massive servers in the cloud, there's one piece of software that's more important than everything else put together. It's the first thing to wake up and the last thing to go to sleep. And of course, I'm talking about the operating system.
You know, you click on it, you tap on it, you interact with it all day long, but its most important jobs are happening totally behind the scenes. So, what is it really doing in there? What are its core functions? That's exactly what we're going to pull back the curtain on today.
So the best way to think about your OS is as the computer's unseen boss. And this boss, well, it basically has two main responsibilities. First, it creates this nice, clean, simplified version of the computer for all your apps to run on. And second, it's the one that has to deal with all the messy, complicated hardware, the processor, the memory, the storage, so your apps don't have to.
To really get a handle on this, we're going to look at the four main departments this boss is in charge of: how it juggles all your programs, how it organizes memory and files, the way it controls your devices, and, super important, how it keeps the whole system safe and secure.
First up, process management. I mean, have you ever stopped to think about how you can have a web browser open, be listening to music, and get a calendar notification all at the same time? It really feels like your computer is a master multitasker, but that's actually a clever illusion created by the OS.
See, the OS doesn't just see a program, it sees a process, which is just a fancy way of saying a program that's actually running. And to keep track of everything, it has this master list called the process table. You can think of it like a super detailed spreadsheet of every single thing the computer is doing right now, from what it's working on to how much memory it's using.
And what's really fascinating is how different operating systems get this job done. When they need to create a new process, they use what's called a system call. On systems like Unix or Linux, they use a command called fork, which just creates a perfect clone of the original process. It's simple, it's elegant. Windows, on the other hand, uses a much more complex command called create process that gives you a ton of control right from the get-go. It really shows you two totally different design philosophies at play.
Now, inside a single program, the OS can manage even smaller, lighter-weight tasks called threads. Think of them as mini processes all working together. And as you can see here, all the threads in a process share the big stuff, like the memory space and open files, but each one gets its own private workspace and to-do list. This is exactly how your web browser can be downloading a huge file while still letting you scroll the page and click on links, all at the same time inside that one single application. Pretty cool, right?
Okay, so let's move on to the next department. A computer is constantly dealing with information, right? Both short-term stuff in RAM and long-term stuff stored as files. For both of these, the OS acts as the system's master librarian.
You know, one of the absolute cleverest tricks an OS pulls off is something called virtual memory. Instead of having all your programs fight over the physical RAM sticks, the OS gives each and every process its own private virtual memory space. This space gets chopped up into pages, and these pages only get loaded into the real RAM when they're actually needed. The end result? Every single program gets to run as if it has the computer's entire memory all to itself. It's a brilliant illusion that makes everything simpler and safer.
And this whole idea of creating a clean, simple picture is even more important when it comes to files. I mean, this quote really nails it. The reality of a hard drive is incredibly complicated. Spinning disks, moving parts, data scattered all over the place. But the OS hides all of that mess and just gives us this simple, beautiful idea, the file.
So how does it actually find anything? Well, here's a peek under the hood. A lot of systems, like Linux, use something called an inode for every single file. Think of it like a card in an old library card catalog. The card itself isn't the book, but it tells you everything about the book, who wrote it, when it was published, and most importantly, exactly where to find it on the shelves. That's what an inode does for your files.
Now, the OS isn't just managing abstract things like files and memory. It's also the direct manager for every single piece of physical hardware plugged into your computer. We're talking your mouse, your keyboard, your screen, the whole shebang.
And here's the key thing to understand. The OS itself has no idea how to speak to every single model of graphics card or printer out there. It would be impossible. Instead, it relies on these special little pieces of software called device drivers. Each driver is basically a translator for one specific piece of hardware. It lets the OS give general commands like print this page without having to know any of the messy, low-level details.
Just take a look at any window on your screen. The operating system is doing two jobs here. It's running the application inside that window, sure, but it's also the one telling the graphics card exactly which pixels on the screen need to light up to draw the border, the title bar, and the scroll bars. It's managing the very hardware that creates the view you're looking at right now.
Okay, this brings us to what might just be the most critical job of any modern operating system, acting as your system's digital bodyguard. It's there to protect your data from both accidents and from malicious attacks. And believe me, the stakes could not be higher. This is a real message from a type of malware called ransomware. It literally encrypts your entire hard drive and holds all your files hostage. A well-built OS is your absolute first line of defense against terrifying threats just like this.
And the OS isn't just a passive wall, it uses some really clever techniques to protect you. For example, when you set a password, let's say dog, it doesn't just encrypt the word dog. No, first it generates a random number called a salt and adds it to your password. Then it encrypts the result. It's such a simple step, but it makes it way harder for attackers to crack your password using pre-computed lists of common ones. So we've seen how the OS is the computer's boss. But when we look to the future, there's this really fundamental debate about how that boss should actually be structured. And this brings us to two totally different design philosophies. On one side, you have what's called the monolithic kernel. This is where the core of the OS, the kernel, is one giant interconnected program. It's the design that giants like Linux and Windows use, and it is incredibly fast and efficient. But the big downside? A bug in one tiny piece of it, like a bad device driver, can bring the entire system crashing down. The other approach is the microkernel. Here, only the absolute bare essentials run in the core. Everything else, drivers, file systems, you name it, runs as a separate, isolated process. It's a bit slower, sure, but it's way more resilient. If a driver crashes, it doesn't take the whole OS with it.
And that leaves us with this really fascinating question for the future of all of this. As we demand more and more performance from our devices, but also more and more security and reliability, which model is going to win out? Are we going to stick with these massive, super fast, all-in-one systems we have today? Or are we going to see a shift towards smaller, safer, more compartmentalized designs? It's this fundamental trade-off between speed and safety that is going to shape the operating systems that we all use tomorrow.